Example 17, finding a horizontal stretch for a tabular function. A function f of x is given as table 13. We want to create a table for the function g of x, which is equal to f of 1 over 2x. So here are our input values, 2, 4, 6, 8. Our output values are 1, 3, 7, 11. Now the formula g of x is equal to f of 1 over 2x tells us that the output values for g are the same as the output values for the function f at an input half the size. Notice that we do not have enough information to determine g of 2 because g of 2 is equal to f of 1 over 2 times 2, which is equal to f of 1. And we do not have a column where we have an input of 1 or an output of 1 on our table. So we do not have a value for f of 1 in our table. Now our input values to g will need to be twice as large to get inputs for f that we can evaluate. So for example, we can determine g of 4. So let's take a look again at what we just talked about, okay? So we have f of 2, which is equal to 1. So if we plug it into the formula, g of x, which is equal to f of 1 half x, which is 1 half of 2. Now, we do not have a value for f of 1 in our table, so our input values to g will need to be twice as large to get inputs for f that we can evaluate. So again, that's why we do not have a column for an input of 1. So here f of 2 is equal to 1. So now we're going to start at g of 4. So if we find g of 4, that means we're taking 2 times x. 2 times 2 gives us an input of 4. 2 times 4 gives us an input of 8. 2 times 6 gives us an input of 12. 2 times 8 gives us an input of 16. So now these are our inputs with an output of 1 for 2, 3 for 4, 6 for 7, and 11 for 8. So now we're going to plug in 4 in for g, and we're going to take 1 half of 4. Well, 1 half of 4 is 2. And we know that the output for 2 is 1. So that means g of 4 has an output of 1. Next, we have f of 4, which has an output of 3. So we're going to use 8 as our input. G of 8 is equal to f of 1 half times 8. 1 half times 8 gives you 4. So f of 4 gives us 3. So now we can see that g of 8 gives us an output of 3. F of 6, which is equal to 7. So g of x is equal to f of 1 half x. So g of 12 is going to equal f of 1 half of 12. 1 half of 12 is 6. And f of 6 gives us 7, so we can see that g of 12 has an output of 7. Last, we have f of 8, which is equal to 11. G of x is equal to f of 1 half of x. So plugging in 16, g of 16 is equal to f of 1 half of 16, which gives us 8. So therefore, f of 8 is 11. So we have g of 16, which is equal to 11. So what happened to our x values? Well, we do the same for the other values to produce that. So we got 4, 8, 12, and 16 as now our inputs. Because what we've done is we've doubled. So 1 half of x meant that we needed to multiply the input times 2. Okay, so because this is 1 half, we had to multiply all the x inputs by 2. And this proved it. So this is our new table. 4, 8, 12, and then 16. So let's take a look at our original ordered pairs. So our original ordered pair here was 2, and then 1. Our original order pair here was 4, and then 3. And then our original order pair here was 6, and then 7. And then our original order pair here was 8, and then 11. So, going back to our original question, okay, it's saying that we needed to take 1/2 and multiply it by the input. So, what we've done now is we've taken 2 and multiplied it by 8 and then kept 11. We took 2, multiplied it by 6 and kept our output. We took 2 and multiplied it by our input and kept our output. We took 2 and multiplied it by our input and kept our output, which eventually became our new ordered pair here. So we got 4, because 2 times 2 is 4, and then 1. Over here, 2 times 4 gave us 8, with an output of 3. And then 2 times 6 is 12 with an output of 7. And 2 times 8 gave us 16 with an output of 11. So because each input value has been doubled, the result is that the function has been stretched horizontally by a factor of 2.